So our learning goal today says I can solve a quadratic equation by factoring. So back in chapter 7 when we were learning how to factor, I said this is going to be this will come in useful when we move into chapter 8 and we have to start solving quadratic functions. So here we are. Now we're going to use what we learned before. So when we are solving quadratics, it's no different by factoring. It's no different than solving by graphing. The solutions are the what? The zeros. So the zeros of the quadratic function are still going to be called the solutions. So let's fill in the second blank first. The solution or solutions. Let's put that little, remember, sometimes you get 1, sometimes you got 2. So the zeros are still going to be the solutions. Well, then that means we have to somehow come up with a way to find the zeros without graphing, without being able to see where it's going to cross the x-axis. So what we need is we're going to have to find the x values where y equals 0 a different way. So we're going to do it algebraically. There is a property called the zero product property. Zero product property is basically this. If one of the factors equals 0, then the product will be 0. Anytime you multiply by 0, I don't care what you're multiplying by 0. You could have 10 factors in a row, and the 0 would be the last one. So you'd be going through all this work, you'd be taking 11 times 3, and then you have to, that would be times 6, and then that would be times 1/2, and then that would be times 7, and then that would be times a negative 3, and then that would be times 1, and then that would be times, maybe, negative 3,000, and you went through all that work and the last factor was 0. What would happen? The answer would be 0. You just went through a whole lot of work doing all that other multiplying because all it takes is one factor of 0 and your answer is 0. So little note to make to yourself. When you see a multiplication problem and there's more than, there has to be 2 factors at least if it's a multiplication problem. Look at all those factors and see if any of them are 0. Because if they are, you know your answer right away. Don't work so hard. Don't worry your calculator out. Right? So if at least one factor equals 0, then the product will be 0. So that means if we can get our quadratic trinomial factored, remember we have a binomial times a binomial. If we can figure out what would make each of those binomials equal 0, because if only one of them equals 0 at a time, that's all we need. But we might as well find out what both of them are. So if x plus a, the first binomial, equals 0, or the x plus b equals 0, the other binomial factor, then our renamed factored quadratic trinomial will be equal to 0. All it takes is one of those binomials to be equal to 0, and when 0 gets multiplied times the other binomial, that's going to mean our quadratic is set equal to 0. And isn't that what we want? We want y to be 0. So let's look at this first one that we're going to solve. X squared minus or plus 4x minus 21. And then it's set equal to 0. Do we need to change that to a y? Are we graphing it? No, we're not solving by graphing today, so we don't need to change that to a y. So we're going to leave it 0. And we need to identify the a, the b, and the c. That's what we need for factoring, along with graphing. We used it also. What's our a value? 1. Calvin, what's our b value? 4. Noah, what's our c value? Negative 21. Okay. Oh, where's this parabola going to cross the y-axis at? If we had to graph this, come on, visualize this with me. Where would this parabola cross the y-axis? At negative 21. All the way down there at negative 21. Is it going to open up or is it going to open down from that? It should open up because why? Because a is positive. Okay, now tell me if it's opening down here at negative. Oh, I wish that was over here. If it's opening down here somewhere, this is negative 21 on the y-axis, and then it's opening up. How many zeros should there be? There should be 2, shouldn't there? It's got to cross the x-axis in 2 locations. So what we're trying to find right now, algebraically, is where will this parabola cross the x-axis, and we're going to find it algebraically instead of having to use the graph to do it. So we need to factor this. So we need what up here?
A times C. Good.
When A is 1, do we need to worry about it?
No.
No. So what do we have up there?
C.
Negative 21, our C value, and what's down here? 4. So we need two numbers that do what? Add up to 4, and when you multiply them, you get negative 21. What do you think he's got them already?
3 and negative 7.
3 and negative 7. Noah? Yeah, if it was 3 and negative 7, Cody, what's 3 plus negative 7?
Negative 4.
Negative 4. So we need the 3 to be negative and the 7 to be positive, right, class? Okay, so now what's the factored name for x squared plus 4x minus 21? X, no. Factored name, the binomials, the unfoiled. Plus negative 3. X plus 7. Or in other words, cleaned up, it would be x minus 3 times x plus 7 equals 0. So we just renamed the quadratic trinomial part of the equation as its factored name, because now we're going to use the zero product property to solve for x. Set each factor equal to 0 and solve. This is really easy. X minus 3. Oh, we don't even need the parentheses, by the way. Get rid of those. X minus 3 equals 0. Set that factor equal to 0 and set the other factor equal to 0 and solve those. Go. Narrow this parabola across the x-axis. What are these points over here? That negative 3 and positive 7, even though it doesn't, I don't really have it kind of looking like that exactly. What did I assume here? That the vertex was on the y-axis. When would it be the vertex be on the y-axis? What did I do wrong here? Is b equal to 0? No. So bad drawing. Let me give a better visual. It is crossing at negative 21. Its vertex would have to be somewhere lower than that. I don't know how much lower, but it's somewhere down here. And then there's this reflection point for that is opening like that. That makes more sense, doesn't it? Because only time the zeros can be symmetric, they can be opposites of each other, is if the vertex is on the y-axis. So that was my clue right there that, oh, you know what, you don't have a good drawing. So this is negative 3, 0, and this over here is positive 7, 0. So we just found it without actually graphing it, doing it algebraically. Yes, no? I don't know. Could you guys tell me that's what it was?
That's just what it is.
Okay, well then, straighten me out. Bad drawing again, third try. Okay, 3 strikes, then I'm out. Okay, then I get to go home. Try this again. It's going to cross the y-axis here, but if one of the zeros is negative 7, the other one's positive 3, where do you suppose that vertex is? Is it in this quadrant?
No.
It's probably in this quadrant, isn't it? Yeah. Okay, I'll try this again, since you're giving me one last chance. There we go. This is ordered pair 3, 0, and this is ordered pair negative 7, 0. Okay. Do I get to stay? Do I have this now? Okay. Let's check it out, make sure it works, just like we had to do when we were graphing, except this time we do have to check both of them because we didn't do any other work to get it. So x equals 3, x equals negative 7. So we're going to put it back into the original equation always before we did anything to it, before we renamed it, anything. Okay, so we're gonna put in 3 and square it. I don't have to put it in parentheses because it's a positive 3. And this is where some of you are stopping and you're just letting that calculator do it and then you're not putting anything else. This is not a check problem. This is a substitution problem. 3 squared is 9. 4 times 3 is 12. 9 plus 12 is 21. Positive, yeah. Take away that 21. And 21 take away 21 is 0. That's a check problem. I'm not going to count them as check problems tomorrow when they don't have that much completion going on. Substituting, typing into your calculator, saying 0 equals 0, not enough. Press this down without that calculator, okay? And then now we'll do the -7, which has to be in parentheses because it's negative. And again, we do not need to use the calculator. -7 times itself is 49. 4 times -7 is -28. And I have that -21. You know what? I'm going to change that to add the opposite because I'm thinking life's going to be easier that way. Plus a -21. Because I always like to add my negatives, the ones with the same sign, I like to add them first.
-49.
That's -49. And then I'll go back and pick up the rest of the equation. And what's positive 49 plus -49? 0. It checks. Okay, so let's go back to that zero product property thing. When we put, let's go back up to here, in this name. When we put +3 in for x, don't we have to put it in both places? Right? So what's +3 plus -3? 0. What's +3 plus 7? 10. What's 0 times 10? 0. Okay, how about the other one? When we put -7 in, what's -7 plus -3? -10. What's -7 plus 7? 0. What's -10 times 0? 0. So we have to find all the possible x values that would create a 0 factor. And it doesn't make every factor equal 0, that one number, but we have to find all the different ones that can make one of the factors 0, because remember, that's all it takes is 1 0 in your multiplication. So we're going to say the solutions are x equals 3 and -7. We checked them out, we verified it, we're feeling like it is right. Okay, let's go to the back side. I think we're going to a couple more to practice. Okay, the first thing we always have to make sure is that it's set equal to 0. Is it? Okay, but we don't replace the 0 with a y today because we're not solving by graphing. So next thing we would do is identify our A, our B, and our C. Because all of those are important when we're factoring it. So what's going upstairs here? -5. What's going down here?
-4.
Okay, why could we just do -5, the B value, or the C value, I mean, up there? Because A is 1. Okay. Go ahead, get that, find out, get this renamed. I want you to rename that quadratic trinomial and in its factor name set equal to 0. Let's see if we agree. What do we do next? Aurora, why don't you sit up and make sorry, not telling you on the left. Thank you. What will we do next? We're solving by factor. So we don't want to draw a graph. Do what?
Add their opposites.
you know, not, gotta do something first before you start trying to do other, what we do in the front with our factors. Set each of them equal to 0 and solve each of them separately. So we set our x minus 5 equal to 0, and we set our x plus 1 equal to 0. And then we probably boast that we think we solved this, but we haven't really until we would check it. We do a check run. We believe this parabola should cross the x-axis at -1 and +5. Let's prove it. In other words, the y value has to equal 0. So we check it in the quadratic name, not the name before it got factored. And we make sure that both of them make that equation true. And we don't pretend that it checks out. We don't say just automatically, but 0 equals 0. Practicing being a lefty. Not going very well. Maybe I could become one. Anybody here left-handed? You're trying to do it. Okay, did yours check out? Legitimately? With all those lines of work? So, no shortcutting our check problems. Any questions on that one? Or I said to Lucy, try the last one totally on your own after we talk about what we should do. Any questions on the last one? Okay. Look what I say about the next one. First needed equal to 0. We can't start this one because it's equal to -9. Now,
AJ Cola to the junior high office, please.
Michaela yesterday when she was doing the work and she was solving by graphing, and her question was her parabola was opening down and my parabola was opening up. Anybody else have a parabola opening down in any of your problems when I had it opening the other direction? Okay, that would be because you chose to move stuff and your 0 was on the other side of the equation than mine was. So if you chose this one to move the x squared and the -6x over to be with the -9, now you've changed it into a parabola that would have what kind of an a value? You're going to move the x squared over to the right side. Is it going to be positive or negative? It's going to be negative. So if we solved it by graphing, we would have a parabola opening down. It still should cross the x-axis at the same places, but you just renamed it differently, and so that's why your graph looks different. Now, if we do that for solving by factoring, do we want to create something other than a equals 1, positive 1, when we don't need to? Do you remember what you have to do when a is not equal to 1 when we're factoring? we have to do when A was, remember, we don't get to just do the diamond, but we also have to do what else?
Did we use that formula?
That factoring by grouping. Oh, another extra step. So when A is not equal to 1, we got to do A times C, and we got to find those numbers that work, and then those become our x's in the middle. Remember how you then had to make a 4-term polynomial, and then you had to do factoring by grouping? Do you really want to work that hard? When you don't have to? No. So what should we do? We want to keep this, right now A is a positive 1, isn't it? We want to keep it that way. So what should we do? Let's add 9. Yeah, let's get the 9 moved over instead. So make a good decision about when it's not set equal to 0. How do I want to get it set equal to 0? Do I want to create, once you're identifying your A, B, and your C, if your A is not a positive 1, it's a negative 1 instead, you know what, say to yourself, why did I do that? I just created more work for myself. And go back and redo it, rename it. Okay, you're ready to go. Get this one solved.
Grant?
Yes,
Yeah, Claire Ann.
I do not.
Thank you. Claire Ann Fulmer to the office, please.
Keep working. What happened? How many solutions are there for this one? Because don't you get the same factor twice? So when you set each factor equal to 0, you still get the same thing. You get 3 for both of them. Is that what happened to you also? Can a quadratic function have only one solution? 1, 0? When is that? When can it have only one? It's going to be a parabola. It's always going to be a parabola with quadratic. It can't change its behavior. Sorry. Corey. When is there only one? Corey, Cody, whatever your name is. D-R, being the alphabet towards the end of the alphabet. I'm sorry. Just call me Tori. Instead of Terry. That's not what you should call me anyway. But, okay. Do you remember what the question was?
Yes. Isn't it because your x?
There's only one solution.
There's only one solution. Your vertex would be either on your y-intercept or your b-value in your problem is equal to 0.
Their b-value isn't 0.
No, but that means that means that your y-intercept is
So-
the vertex.
So the y-intercept is the vertex then. I thought the y-intercept was the vertex when b was 0. It is, isn't it? Dante?
The x-intercept is the vertex.
The what?
X-intercept or minus x-axis.
So the vertex is this point in other words? Let's draw it like this. Let's go. So where's this? Is this saying that right here at 1, 2, 3, right here at 3 is our vertex, right? Because this is the only place it's going to cross the x-axis is right here. It's the only 0. So it's the vertex. Is it on the y-axis, Cody? No. What's it going to do? Is it going to open up or open down?
Oh.
It's going to open up. This is one of those that when you solved it by graphing, this is what would have happened, right? So we would say that we really only need one solution, which means we only need one check problem, right? There's only one solution, so we're going to check our 3 into our original equation. So you've already done this check problem. You're out of luck. You got to go back and do it over if you didn't do it in the original equation. We have to, just in case we renamed it wrong, we're going to go put it into its original name and make sure it checks out. 3 squared is 9. Minus 6 times 3 is 18. 9 with a long subtraction sign. 9 subtract 18 is -9. Because we want it to be or because it really is? Because it really, truly is. It checks out, doesn't it? So only one solution for this one. It is x equals positive 3. Okay. Questions? Aren't you glad you stuck around and learned this way? So you don't have to keep solving by graphing? Oh, you want to solve by graphing still? Okay, go ahead, but you do the solving by graphing for these 7 problems that we have from home, 8 problems we have from homework, and the rest of us will do the factoring way. Would you keep track of how long it takes you? And by the way, you have to provide your own coordinate planes. And for the rest of us, you keep track of how long it takes you. Okay?